Okay. So, we are talking about ratio tables. So last week we talked about ratios and rates and unit rates, okay? So with a ratio table, it's basically the same thing. We just have another way to organize our information to help us find missing values. All right, if you look at this, a table with columns that are filled with equivalent ratios. What does that word equivalent mean? Equal or same, exactly. So what we're looking at ratios that, if we were to look at them as fractions, if you look at this, 1 to 3, 1/3, is that not equivalent to 2 to 6?
Yes.
And 3 to 9.
Yes.
Okay? So this would be an example, and what they're talking about, the concentrate, that would be like juice you would buy in the frozen section, and you would mix it with water to make orange juice or whatever. So for every 1 can of concentrate, you would need 3 cans of water. So you have that 1 to 3 ratio. Well, if I did 2 groups of that, then that's where you would end up with a 2 to 6 ratio, and then 3 to 9. Okay? What am I adding every time up here? Plus 1. Okay? So I'm adding plus 1 up here. What about the bottom? What am I adding?
3.
Plus 3. Okay? So we're looking at a plus 1 and plus 3 equivalent ratio. Okay? So every time you add 1 of something, you're adding 3 more of the other. Do y'all remember, it's been a while since we've talked about this, but when I'm thinking about things using addition, do you remember what that's called? What kind of reasoning? Close. Additive. Okay, so it's additive reasoning. Okay? So we're thinking about this using addition. But that's not the only way we can look at it. What if I didn't have those 2 numbers in the middle? How do I go from 1 to 3? Nope. How do I go from 1 to 3? Times what? Well, not necessarily the bottom. If I want to get from 1 to 3, I'm going to multiply by 3. So to jump from here to here, we can multiply by 3. Okay? And yes, this column we'd be multiplying by what? 2. Okay? So this, do you remember what type of reasoning that's called? It was that real fun word.
Simple. Adjective. Multiplication.
You were very, very close. Multiplicative. Okay? So, multiplicative. You can sound really, really smart. So, this would be additive reasoning when we're thinking about how many we're adding each time. But when we make those jumps, we're using multiplicative reasoning. Now, you guys are in 6th grade. Okay? We don't want to always use this additive reasoning. Okay, because we know it's much quicker to take that shortcut and use multiplication. So in most of our problems, we're going to be thinking multiplication and division. All right? So let's look at an example together. Santiago receives an allowance of $7 every week. How much total does he receive after 4 weeks? So if I look at this, what did I do to jump from 1 to 4 weeks? Times 4. So here's the thing. When I'm dealing with multiplication and division, just like with fractions, if I do it to the denominator, what do I do up here? Same thing. So 4 times 7 would give us 28. Now, we can go in and fill in the rest of our chart, because this would be for 2 weeks. How much money?
14.
And for 3 weeks? Okay. But the answer we're looking for is actually right here. So we would say he has $28 in 4 weeks. Okay, but do you see how I did this using multiplication? And then if I had to go in and do adding, I could. Okay? Now, this is a very simple one. Let's talk about what happens when it's not so simple. All right? Tanya runs 8 kilometers in 60 minutes. So there's our initial ratio, 8 to 60. At this rate, how long would it take her to run 2 kilometers? Hold your hand. I don't want just the answer. I want us to talk through it, okay? So how do I get from 8 to 2? Divide by 4, okay? So I'm going to do the same thing to the bottom. So what is 60 divided by 4? 15. So what this means is that 2 kilometers took her 15 minutes. Oh, that's pretty fast, I think. I'd have to look at that. Yeah, that is pretty slow. Alright, so let's look here. Could I find found another equivalent ratio to fill in with the middle. What if she only ran 4 kilometers? How long would it take her?
30 minutes.
30 minutes. Excellent. See how you're using that relationship to figure out the patterns? Okay? Sometimes those patterns are what are going to help you get from one point to the next. Okay? Do you see where I got the 4 and 30?
Yep. Yeah.
No? Okay, hold on. Look. If she ran 8 and 60, how did I get from 8 to 4? Divide by 2. So then I just take the 60, divide by 2. That's how I get the 30. And then if you even wanted to go further there, I could do 4 divided by 2 to get to 2. And 30 divided by 2 would be 15. Okay? All right. A certain 12-ounce soft drink contains about 10 teaspoons of sugar. If you drink 18 ounces of this soft drink, how many teaspoons of sugar have you consumed? Now, let's look carefully at this. Do I have a way that I can multiply or divide easily with a whole number to get from 12 to 18?
No.
I don't. So this is like that problem we were doing a little bit yesterday. What number could I use as like a stepping stone in between 12 and 18?
15.
Well, but I don't have an easy way to multiply to get...
10.
Can I use 6? Let's try it. So let's do this. I don't want to multiply by 6, but I want to use 6 as like my little guidepost, okay? So then I'm going to ask myself, how did I get from 12 to 6? What did I do? I divided by 2. So I'm going to do the same thing down here. So what is 10 divided by 2?
5.
Okay. So now, how did I get from 6 to 18?
3.
Times 3. So I'm going to do the same thing down here. So 5 times 3 is 15.
Miss,
Yes.
I just saw it like this. In my head, I pictured that 12 times 1.5 equals 18.
Mm-hmm.
So I just multiplied 10 by 1.5 and got
That's okay. That's fine. I'm just showing you that basically what you're, and that's fine because what you were trying to figure out was, the actual, and that's fine. You can do it that way. For most people, they're going to need something else to kind of go back to. Okay? Alright, but do you see how all of these are equivalent? 12 to 10 is the same as 6 to 5, is the same as 18 to 15. Okay? So our actual answer would tell us that for 18 ounces, they had 15, is it teaspoons? Yeah, teaspoons of sugar. So 18 ounces for 15 teaspoons. Be careful. The table is not your whole answer. You've got to actually go in and answer the question, okay? And that would be our answer right there. Alright, let's try one more together. And this one we're actually going to draw our table. And I want to do this one for you 2 different ways. Okay? So we've seen a table like this. We're going to do one vertically. So we know that she bought juice boxes. Alright, and we know that she paid, how much did she pay for them?
$48.
$48. Okay? So she bought 12 packs, and that cost her $48. And we want to know the cost of 8. Okay, so looking at this, what can I use as a stepping stone to get from 12 to 8? What could you use, Bennett?
Benny Forbes.
Wait,
Let's don't do that.
Times.
it says 8 more, so what did I use?
Well, no, she's just going to go purchase 8 more.
Hey, it works.
She doesn't need 20. She just needs to buy 8 more. Yeah. No, but I did think about that first, too. We could use 4. What about 1? Could I use 1?
Yeah.
Okay. So what happens when I have the cost of one thing? What do we call that? Unit rate. Bingo. So what would the unit rate of those juice boxes be? We paid $48 for 12. How much is she going to pay for 1? 4. Okay? So once you figure out that unit rate, that cost for one item, and again, I'm going to draw you a little arrow. This is our unit rate. Okay? How did I get from 1 to 8?
You multiply by 8.
Times 8. So 4 times 8 would give me
32.
32. So your answer would be for 8 packs. She paid $32. So $32. Yeah, when I wrote the chart, I was going by the way they listed it, and I should have done that.
Yeah, those are random people that came up with this one.
It's all right. And so we'll look at it as $32 for 8 packs. Now, let me show you something. We did this using multiplication and division, right? What if I had done a 2 right here? Would that work? 12 divided by 6 will give us 2. So 48 divided by 6 will give us 8. And 2 times 4 gives me the 8. So 8 times 4 is
These juice boxes.
32. You get the same exact answer. It's fine that you use a different number. And here is why. Okay, at the very beginning when we did that chart on the allowance and the number per week, okay, so if we have boxes and cost, we figured out 1 box costs $4. So 2 cost 3 cost 12. 4 cost 5 cost 20. Do you see how each time I'm adding 1 here and each time I'm adding 4 here? That's our 1-to-4 ratio. That's what you're doing over here, just shorthand. Because look, we would have had to go down to 8 boxes before we got to our 32.
Dang.
So this is much shorter than what we're doing over here. Okay? So I am this time actually providing you with a shortcut. Alright? So what we're going to work on, and I'm going to go ahead and stop this. We're going to do some more of this tomorrow, so don't worry if you don't have it quite yet.